Now we're going to try to find the limit of this series, and the reason I'm saying the limit of this series or it converges because you can see this here, that this quantity or the nth term of this sequence is less than 1 over n square, because the denominator here is bigger than the denominator here. And then we know this, that this series here, it converges because the power is greater than 1 here, okay, because 2 is greater than 1, so the P series converges. So what we have to do is that we have to try to find the sum that it converges to. And for that, remember this, that in order to do that, I mean, it's not a geometric series as you worked on that before, so we will look at the sum of the nth partial sums. So what we are going to do there is that we are going to add the first n terms. So here what we get, 1 times, here I have 5, right? Then 1 over 2 times 6. So I wrote the second term. Okay, so what am I doing? I'm finding the nth partial sum, and then I'm just going to keep on doing that just for a little while. So this is 3 times 7, okay, and then plus we got 1 over 4 times 8, okay, then plus 1 over 5 times 9, okay, 9, and then at the end we will have the nth term, okay, and what the nth term, one moment, okay, plus, so I'm going to write it at the end and then just bring in the other ones before. So here we have the big nth term, and that is going to be what? N, and big N plus 4. And just for sake of like understanding it better, let's just write the term right before that. So what the term right before that would be, that will be n plus 3 here, and then n minus 1 here. Sorry, the screen is getting cut off. Let me just bring it all in view. I think this should give us a pretty good idea. Okay, so now let's notice one thing here. All these are just like, products, and the difference between the factors is 4. So if you do this, if you apply partial fractions on this, what it will be? It will simply be 1 over 4n minus 1 over 4n plus 4, because of the method of partial fractions, or you can combine them and check. So what happens as a consequence of that is this, that here you can see our n is 1 and n plus 4 is 1 plus 4, that is 5. So this would be what? This would simply be 1 over 4 minus 1 over 4 times how much? 5, right? And then it would be this, if you factor a 1 over 4 out, this will become 1 minus 1 over 5. I'm writing 1 over 1 as 1, okay? So you can now go ahead and expand entire Sn in this manner, and I'm going to do this here. That is, let me just write it in the next line. So this changes to, as you saw, 1 over 4 times 1 minus 1 over 5. And actually what we can do is this, that we can treat 1 over 4 as a common factor for the entire series. So here we will get 1 minus 1 over 5, and this and again 1 over 4 has been factored out, so this will be 1 over 2 minus 1 over 6, and then this would be 1 over 3 minus 1 over 7. Okay, 3, 7, and then this guy will be 1 over 4 minus 1 over 8. Okay, minus 1 over 8. And let me just make the fonts a little smaller, not too much. And then you have 1 over 5 minus 1 over 9. And the next one down would be plus 1 over 6 minus 1 over 10 and all that. Okay, and here we got this, like if you look at this portion, 1 over big N, sorry, minus 1 over and plus 4, and plus, sorry, 4, that went a little over there, and this would be 1 over n minus 1 minus 1 over n plus 3. Okay. Now see what happens is this. So one moment please. Plus this. Okay, good. So if you look at this entire expansion, what you will notice is this, that we have, see this here, this 1/5 is going to be cancelled by this 1/5, and 1/6 is going to be cancelled by this 1/6. Okay, and the term next to this would be 1 over 7. This was 1 over 6, so here we will have a 1 over 7 that is going to cancel this 1 over 7, and then after that 1 over 7 we will have 1 over 8 coming up, so that will cancel. So the only survivors in the beginning would be these 4 terms, and likewise many terms towards the end will also cancel, okay, right here, and whatever is left over will just go to 0. Okay, so what happens here is this, that our S capital N will go to what? As capital N goes to infinity, 1 over 4 times 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, because what we will have is this, that towards the end we'll have only 4 terms remaining towards the end that are functions of n, they will go to 0, and everything else here cancels out. Okay, and so this would be, you can use the sum sequence feature in your calculator to calculate that this sum goes to how much? 25 over 48, and you can take a decimal approximation if you would like. And actually, if you would like, you may try to see this, try to check the following statement. That is, say I have a series of this type, okay, a series n goes from 1 to infinity, all right, and the form of the series is this, that it is f function of, sorry, n minus n replaced by n plus k, where k is a fixed positive number. Okay, and then let's assume for now that is f is always greater than 0, that our fx is never negative. Okay, so if we have this, that fn goes to 0, okay, sorry, then this will, I mean, I'm leaving it for you to check, okay? All right, I'm not writing proof of this. So this would be what? This will simply be f1, okay, plus f2 plus f, how much? fk, okay? All right, so that's what this will converge towards. So see if it is true, okay? See if it is true. That will make the above job much shorter. Sorry, I forgot to erase this here. Okay, all right, so this is a, and this will be, as I said, this will be a shortcut to find the limit if it is true, and I'm leaving it for you to check. Okay.